Welcome back to the midterm review for winter 23, and we're at problem number 9. Starting in this table, it says the following table shows the pesticide status in a random sample of food types, organic and conventional, sold at supermarkets in California. So we've got one variable is either organic or conventional, and the other one is either pesticide was present or pesticide was not present when they sampled the food. So if we take the totals, the place I'm going to start is adding the pesticide, and we get 19,514. And then we can add that to 7184 and validate that it's the total of 26,698. And then I can use 7184 to find out that this should be 98. And then I can add 29 and 98 to be 127. And I can add 19,485 and 7,086 to get 26,571. And when I add those again, I can validate. So once I have the table filled in, I'm going to go and answer the questions. It says, what is the probability with that they chose a random food that had pesticides present? So pesticides present would be all of them. So that would be 19,514 out of 26,698. You can give it in 4 decimal places. What is the probability that you'd choose a random food that is not conventional? So not conventional would be organic. So that's the same as the probability of organic, not conventional. And that would be 127 out of 26,698. And that is 0.0048. D says the probability that it is organic and has pesticides. So and means they both have to be satisfied. It's an and. That means they're not mutually exclusive because there is an and, they intersect. So organic is the top row and pesticides present is the first column, and they overlap at 29 out of 26,698. That is equal to 0.0010 1, 2, 3, 4, 1. So 0.0011, 4 decimal places. E says that it is organic or conventional. So organic or conventional means it's organic, so the top row, and conventional is the second row. And so because they are mutually exclusive, you can't view them at the same time. There is no overlap. So it's no overlap to worry about there. So we can simply add the 127 plus the 26,571 out of the 26,698, and that equals 1. That's everybody. F says that it is conventional or does not have pesticides. So conventional would be the second row and does not have pesticides is the second column. But because they overlap, we have to subtract that, so it's not counted twice. So we have 26,571 plus 7,184, subtracting the overlap of 7,086, all over 26,698. And that is 0.9989. And G says, what is the probability that it is organic given it is pesticide not present? So given means we're going to be only out of the pesticides not present. So it's going to be out of the total of 7,184. It's a conditional probability. So what is the probability that it's organic out of those that are pesticide is not present? So that would be 98. and that's 0.0136. That's question number 9. So let's look at question number 10. Question number 10 says, a store sells ski boots in 2 colors, yellow and red. The following sizes are available, small, medium, and large. Make a tree diagram to show all possible pairs of ski boots if color and then size are chosen at random, and create the sample space. So if we're first going to choose color, we could have yellow or red. And once they choose color, we have to choose size. And there's 3 sizes, so they could be medium, small, medium, and large. And over here, small, medium, and large. So my final sample space is putting it all together. And if I wanted to know how many are going to be in the sample space, let me just write that up here. How many in the sample space? I've got 2 things I'm deciding. First, I've got 2 color choices. And then I've got 3 sizes. So 2 times 3 is 6. There's going to be 6 in my sample space. So I'm going to have yellow small, yellow medium, yellow large, and then red small, red medium, and red large. Okay. Now let's look at problem number 11. It says your company is considering developing one of 2 toaster models. The projected profits are shown in the table. So we've got toaster A and toaster B, and it looks like they both have a possibility that they could lose money, but they both have some good possibilities of making money. So A says calculate the expected profits for each toaster, and then we're gonna answer some questions about them. So let's go ahead and head to Desmos. Okay, so to find the expected profits, I had to make 2 tables. So here's a table for toaster A, the profits, possible profits, and then the likelihoods, the probabilities in Y4. And because these are in probabilities and my Y4 totals add to 1, I don't need to divide by anything because I'm going to divide by 1. Whereas the weighted averages, I have to divide by the total Y column because the frequencies could be different. So I don't have to divide by a total Y column here because they're going to add to 1 anyway. So my expected profit for toaster A is $165,000. And my expected profit for toaster B is $190,500. Okay. And it's interesting because they both look like they have some really good possible profits. So it says, which toaster is the better choice for development based on expected profits? And that would be toaster B. It has a better likelihood of overall success. C says, if you're a CEO who's a big risk taker and an optimist, which toaster is the better choice? And the optimist is probably going to go for project A because that's the optimists always look at where they could possibly make the most money. They could make $500,000. They don't look at the fact that they could possibly lose money. They look at the best possible optimist option. So that would be toaster A. Catch me back for more problems for the review.